Motion recording experiment 9, dynamizing that. So this experiment is about hierarchy clustering, and here we're going to see two algorithms under hierarchy clustering. One is agglomerative and the other one is divisive. So in agglomerative now we're going to use the I2 data set, and we need a normalized function. We're going to define a function called normalize. It's basically to normalize the function to a value between 0 and 1. And we can apply the normalized function on the data set called data and on the first four columns, that is 1 2 3 4, and we're going to store it in a new frame called data1. And once you have done that, you're going to use data1 and you find the Euclidean distance between the instances, and you're going to store it in a variable called d. And there are different methods for finding the distance, and Euclidean is one of the prominent methods, and we have that. Then we use a function called hclust. Hclust is a function which performs clustering in here, and we're going to use the method what.d. If you look inside the hclust function, you can see the methods. There are different methods to do it: what.d or what.d2 or single or complete. We have actually performed. I'll show you another clustering, that is agglomerative clustering, with the hclust function with the method complete later. And we're gonna plot. So let's run the code first. So this is the plotted value. You can when you zoom in, you can see this is what we have. This is the dendrogram, and if you try to plot some rectangles to easily view the plus, we use the right.h+. Now if you look inside the zoom plot, this is how it is. This is how they have been clustered. One is Virginica, one is Heterogena, and versicolor. And we can use the cut-tree algorithm, cut-tree function, to divide them into different groups, and that's what we do here. Then we plot the confusion matrix. So in the confusion matrix, the desired values are in the diagonal, the rest are the undesired values for the error. So we calculate the mean class error by taking the sum of the diagonal values and dividing it by the sum of dot values in the table, and you subtract that from 1, so you get the mean class error. And here we have the error value of 0.11, which is not so much, and we later apply the same technique but using a different method for clustering, that is the complete method. And let's see what we have. So here when you run the code, yep, so this is what you get. And if you look at the mean class error, you have a different value. So it's 0.12. As you can see, both algorithms perform differently, different clustering techniques when the methods are different. And I'm going to look at the DVC algorithm. So this is the algorithm, and you're going to use the OPART package to perform the functions of this algorithm. So first we import the packages we require. Then we use the same dataset as iris dataset, and again we define the normalized function. Then we're going to normalize the data we have, and we're going to use a function called Diana. Diana is another DVC clustering algorithm. So it comes under the package OPART, and we're going to run it and see. Yep, this is what we have. So these are the available components inside the inside DV, and this is what DV looks like. So it has a lot of components, and there is a lot of data under each component. And here for Diana we use a metric Manhattan. So even Diana has a lot of different metrics other than Manhattan. Now what we're going to do is we're going to try we're going to again turn them into groups, divide them into groups. So using the cut tree, and we're going to make the confusion matrix. So we have the confusion matrix here, so we have the desired values again in the diagonal and undesired values which are not in the diagonal. So now After that, we're going to apply the same dynamic function using a different metric. So here you're going to use the Euclidean metric, and you're going to do the same sequence of steps. So let's see first. This is the plot, and we're going to divide the plot and looking, and in the end we're going to see the table. So let's see the table. This is the table, the confusion matrix we generated. As you can see, it's different than what we had in the previous one. So this is table 1 and the previous one is table 2. As you can see, the values are different. There is a big difference in error. So we're going to use this function. We're going to use this technique and see how much matching there are. So there is false, 6 false and 144 true. And now what we're going to do is we're going to plot a dendrogram and dv of 0. This is a dendrogram, and the dv of 0 is basically nothing but the first model we created using the Euclidean metric. And of dv, this is the plot for dv, and you can see that here, and this is the plot for dv of 0. So that is using the Euclidean metric. The first one using the dv was with the Manhattan metric. And that is all. Thank you.